Um, so in the last class we have studied about the DC generator and motor. Now in the today's lecture we'll cover AC generator and motor. Okay. So if you remember, I told you that AC motor is further categorized into two categories. One will have the induction motor and another will have the synchronous motor. So what is the main difference between these two motor? That in induction motor we can change the speed, right? And in synchronous motor speed is always constant. Okay. So basically what is the formula for the constant speed? Constant means synchronous. So that synchronous speed is denoted by ns. N is denoted by speed. N is for speed and S is for synchronous speed. So what is the formula for that? That is 120 F divided by P. What is F over here? F is the frequency. Okay, as you know, in India we are using 50 hertz frequency, so frequency won't change, so frequency is fixed. What is P over here? P is the number of poles, and you all know ki if we have made machine, then we can't change the poles also. That means poles is also fixed. So if poles is fixed and frequency is also fixed, then speed will also remain fixed. Okay. Now let's talk about the induction motor. In the induction motor, speed depend on various things, so that's why we can change the speed of the induction motor. The best example of induction motor is we are using fan. In the fan, which motor we are using, that would be the induction motor, because we can change the speed of the fan. Okay. Now I am telling you about in detail about the induction motor. Induction motor is further categorized into two categories. One is the single phase induction motor and another one is the three phase induction motor. As you all know about what is the difference in single phase and three phase. In the single phase will provide single wire which is providing current, and in the three phase we are providing three wires like the sequence of RYB, which is providing current, right? So basically what is induction motor, we'll study about the detail. As you know, in the first of all let's study about the construction of induction motor. We have studied already about the construction of DC machine, so maximum there is a chance ki construction will ask, maybe they'll ask from the DC part or they'll ask from the AC part. Okay. So in every machine we'll have two things. One is the stator, as you know. Another one is the rotor. What is stator over here? Stator is the stationary part. And what is rotor over here? Rotor is the rotating part, right? So in particular induction motor, I'm telling you, in between there is a shaft, as we have studied that there is a shaft in DC machine also, and in the outside we are using stator. Okay. Now instead of using a plain circle wire, we'll use the stator like this. Remember, we have used this kind of windings or this kind of shape in DC in rotor winding, right? Armature. So DC के रोटर को what we call it as a armature, but induction के रोटर को we don't call it as a armature. It's not necessary कि हर बार we are saying कि rotating part is armature. No. Okay. So this one is the stator. Okay. This one is the stator slots, and in each slots there is a conductor. That depends on requirement. I am showing one conductor in each slot, so we can call it as a stator winding. Okay. Now in between, then after the stator what will be there? Rotor. Again rotor will be of the same shape, same winding kind of. So this is technically known as rotor. Again we'll have rotor slots, and in that we'll have rotor conductor, that is known as rotor winding, or we can say it as rotor conductor, and outside one is the frame. Technically we called it as a yoke. Okay, understood? So draw this diagram first. So technically in the construction, what are the different parts? First one is the frame, right? Frame, you know कि outer covering के लिए, that is used for mainly mechanical protection. Second thing we are using, that is air gap. You know what is air gap? As you know, this the whole part, green part is the stator and this yellow part is the rotor. So there must be some air gap between green part and yellow part, means stator and rotor. Then only rotor starts rotating. Now if there is no gap, then rotor will be able to move. No, now. So there must be some air gap between the rotor and the stator. Third thing we are using in this, that is fan. As fan rotates with rotor. Basically what is the function of fan? It is used to cool down the motor. Okay. So how, in whichever speed rotor is rotating, at that particular speed fan is rotating. So basically like एक साइड से दोनों चीज हो रही है कि rotor is rotating, similarly fan is rotating, and this induction motor produces lots of heat. So we need one device which is used to cool down the motor. Fourth thing we are using in this, that is known as slip rings. The rotor windings are connected to the slip rings. I'll tell you in detail later on about the slip rings. What is the function of slip ring and what is the use of slip ring? So there are mainly 5 parts we are using in the construction part. Okay, here. Now based on this, the induction motor is divided into 2 categories. Have you seen any induction motor? Now in the construction only you need to write this part, that if they will give you the construction, that there are 2 types of induction motor. Okay, what are those 2 types? First one is the squirrel cage induction motor. Second one is the wound rotor, or we can say slip ring induction motor. Generally they'll ask you, if they'll ask you that you have to explain the construction of induction motor, types of induction motor must be included in that only. Okay, so let's discuss about the wound rotor or slip ring induction motor. In this, first we'll provide the supply. We'll provide in this the 3-phase supply. Okay, and as you have already studied that 3-phase supply is generally divided into category. One is the star connection and another one is the delta connection. So we need to take the star connection in the slip ring motor. I'll write it down, which it is slip ring type rotor. Okay, so we are providing with the supply, and then supply is connected to the shaft. Okay, now what is shaft? Now this is a shaft, and in the shaft we'll have 3 slip rings. Okay, we'll always have 3 slip rings which is connected on the shaft. I'll show you practically also. And that slip ring is connected with the brushes, and brushes is connected with the external resistance. So this one is slip ring, this one is brushes, and this one is the variable external resistance. Okay, and in this, why we are connecting the external resistance? Because through external resistance we'll be able to control the amount of current. So that's a plus point in in slip ring induction. I'll show you practice. So this is a practical inductor. As you can see that this is the cut view structure of the machine. In this there is a fins. Fins are used. I'll tell you what is the role of fins. And you can see that this one is the rotor, right? This one is the rotor, and I told you that rotor windings are like this, right? So you can see that the shape of exactly the rotor windings are like this only, right? and see clearly, you can see that there is a winding in these, right? There is a wire connected in these slots. Okay, there is a wire connected in these slots. So this is technically known as rotor. This part is rotor. Okay, now come on stator. As I told you, stator also have the same frame like this. See this red one, you can see the red one now. This red one is the stator. Okay, and as you can see that stator is also the same kind of shape of this, like this only. Okay, and this one, outer one is the frame rotor, and there is a fan is connected here. They didn't show the fan, but fan is connected over. Okay, now I'll show you the slip. See exactly the rotor looks like this. Okay, as you can see that there is a shaft, right? I told you the shaft, and on the shaft will have three rings, right? On the shaft will have three rings, this one three rings, and there is a connection of connecting the external resistance with the help of brushes. This one is the rotor, and as you can see there is winding over rotor. So exactly the slip ring motor looks. Now understood? Now next category, squirrel rotor या फिर squirrel cage rotor. As you can see, the cage like is like a jail, right? So it's a cage like structure, and this is the rotor. So how will we show this? That there are two rings at the end. Okay, these two rings are attached with the windings, and these windings are mainly of material of aluminum bars. Okay, so this is a slip ring rotor. In the slip ring will have three slip rings, but in the squirrel cage won't have slip. In the slip ring rotor, we can attach the external resistance, but in squirrel cage, we don't have any option of connecting the external resistance. Okay. So how in the paper, how will you like ना कि से एक तरह से like a balloon kind of structure वैसा हो गया ना? So how will you draw the diagram of circle? Draw bars like a circle. What does this circle show? That's one. Okay. So अगर मैं तुम्हें डायरेक्ट बताती this structure, then you won't understood. So I need to the diagram first, that exactly the squirrel cage rotor is this one. Okay, now I'm telling you the difference between the squirrel cage motor and wound rotor. So the very first difference, that in this no slip ring, right? But in this slip rings are there. In this no brushes are there, right? But in wound rotor or slip ring motor, the brushes. The construction of squirrel cage is simple construction, but in this will have complicated construction, right? Here external resistance can be connected. Here no external resistance can be connected. In squirrel cage will have a small or moderate starting torque. Starting torque means कि starting में जैसे मोटर घूमती है तो small torque is generated, but in wound rotor high starting torque can be obtained. High starting torque means there are some motors ना starting में बहुत धीरे धीरे घूमती हैं and then it will attain the speed, but there are some motors जो starting में ही तेज घूमती, right? So that is high starting torque means starting में स्पीड ज़्यादा होती है, लो starting torque means कम होती है. Okay, now in this it will have higher efficiency and it will have lower efficiency, mainly where we are using the squirrel cage, that is we are using in fan motor. Squirrel, as you said, water pumps means cooler pumps. Okay, blowers, all these are squirrel cage. In this there is a crane, elevators, compressors, or in these all kinds will use rotor, and in this will use squirrel cage. Okay, clear? Now after that, the most important principle of three-phase. Okay. So as you know, outer part will have stator, okay, and inner part will have rotor, and will provide the three-phase induction. We are providing the three-phase supply, that is R, Y, B, right? Yeah. So R, as you know, R is of red color, Y is of yellow color, and B is of blue color. So as you can see that we are providing the three-phase supply, three different wires and three different currents. So that wire is connected like this. Here R is connected. So it actually, how it looks like, that R is connected, R winding is connected over here winding. Similarly, yellow color winding is winding, and similarly color wire is connected to the stator winding like this. Okay. So as you know one thing, that whenever there is a wire and current is flowing in that wire, then that means magnetic is also produced. Yes or no? Whenever you are carrying a wire and that carrying current also, then that wire produces magnetic. So magnetic field is produced over here also, magnetic field is produced over here also, and magnetic over here also, right? Clear? Now we are providing the three-phase supply. If you go out in detail of the three-phase supply, that one supply always start with and changes its cycle at 180 degree and complete its cycle at 360 degree, right? One another supply will get from the positive side, and then it will move like this, and another supply will get negative side, and it will, one supply will start, it's not fixed that red is always from the, I take it randomly. So in this case we'll always see that one supply move it 0, another will be from positive, and another will be from negative. Now in this particular section, as you can see that there is no current same in any of the portion. Like suppose I take this portion, here the red wire is positive, the higher value, blue wire is also positive, blue current means current is higher, low current value is positive. If we'll see for the yellow, then in that case yellow current is in the negative. So if you see at any particular point, you can see that current is not same, right? Understood up to here? So every time current is changing, if current is changing, magnetic field also keeps changing, yes or no? As you can see that current keeps on changing and every instant of time. Similarly, with the magnetic field produced from the current only, that will also keeps on changing, right? Tell me, any doubt up to here? So magnetic field keeps on changing. Like suppose here the magnetic field is higher, then lower, then further more lower, then higher, then lower, then further more low. So it seems like that magnetic keeps on rotating. Yes or no? Because current is changing. There in the particular pattern, current is changing. Now first it then increases. All the currents are changing in a similar pattern. So on the similar pattern, magnetic field also keeps on changing. So if magnetic field keeps on changing, then it seems like that magnetic field keeps on rotating. And technically what we called it as a rotating magnetic field is denoted by the term Rm. Okay, So basically what we can say, through three-phase supply we are giving a rotating magnetic. Okay, it's, see, I'm again saying it, magnetic field is not rotating, but sometimes says it's higher, sometimes it's lower, so it seems like that magnetic field is rotating, and technically it is known as RMF, and that is, RMF is produced only in case of three-phase supply, not in the single phase. So what we got it up to here, that we are giving the three-phase supply, and on the stator we are getting RMF. Understood? Now see the next part. We are studying about the motor, right? That is induction motor. In the motor we are providing electrical energy, and that electrical energy is converted into mechanical energy. So see, here we are providing electrical energy, and due to that electrical energy, rotating magnetic field is produced, right? Still we are not getting mechanical energy, right? Because when we'll get mechanical energy, whenever rotor starts. Understood? Any doubt? Now see how rotor starts rotating. Just see the concept. As you have studied the basic concept I told you earlier also, there is a magnet, okay, and if we rotate this coil, then in that case it will cut the magnetic field lines. Yes or no? I am repeating that if we rotate this coil, then in that case it cut magnetic field lines, right? And if magnetic field lines will be cut, then in that case flux will be cut, and if flux will cut, then flux will change. And according to Faraday's law, that whenever there is a change in flux, that according to this formula, then whenever there is change in flux, then in that case EMF will induce and current starts flowing in the coil, right? That I already told you. But now I'm changing minor things in this. See what I change. Instead of rotating the coil, okay, instead of rotating the coil, I'm rotating the magnet. Now I am rotating magnet, and coil is stationary. Can we do this thing also? Here coil is stationary, here coil is moving, magnet is stationary, but here we are rotating the magnet and coil is stationary. Now particularly in this condition, tell me, in this condition, if magnet is rotating and coil is stationary, then in that case also EMF will induced in the coil or wire, yes or no? Because flux will change now, because it will cut the magnetic field lines, and if flux will change, that case EMF will induce, right? So as you can see, there is a similar situation over here, that there is a magnetic keeps on rotating and the coil in between is stationary, right? So due to the Faraday's law of electromagnetic induction, if magnetic keeps on rotating, means rotating magnetic field is there, coil means rotor inside is stationary, then due to Faraday's law of electromagnetic induction, flux will change, and if there is change in flux, then EMF will induced, current will flow in the rotor. Understood this part? Write it up to here. Now see, after that we are giving which energy? Electrical energy, right? Up to here we are getting which energy? Electrical energy only, we are not getting mechanical energy till now. But see, after that what happens? There is a rotor, and rotor produce, after that what happens? Electrical energy, the rotor, right? That electrical energy converted into magnetic energy, yes or no? There is a electrical energy, the rotor is a electrical energy, the rotor, and that electrical energy magnetic. So now as you can see that there are two magnetic. One is the magnetic of stator, and one there is a magnetic of. Both will interact with each other. Yes or no? Magnetic field is produced in rotor, right? Magnetic field is there in the stator, so both magnet will interact with each other. Now you tell me, who will move, the stator or the rotor? Suppose if there is a north pole and north pole, north and north repel with each other, then it will try to move away from each other. Now tell me, stator will move or rotor will move? Stator is the stationary, so stator can't move. Who will move? Rotor. And the rotor starts rotating. So up to here it is completed. We are giving electrical energy, but we are getting mechanical energy as rotor starts rotating. Okay, I am repeating from the starting. What is the principle of induction motor? So this one is the stator. Okay, and in the stator, I am repeating this, stator is supplied with a three-phase supply R, Y, right? And due to the three-phase supply, there is a generation of magnet will keeps on rotating. Basically, suppose red wire is generated over here, red wire is connected over here, yellow wire is connected over here, blue wire is connected over here, so that there is electrical energy, and electrical energy is converted into the magnetic energy, and magnetic field keeps on rotating because current is changing, so magnetic field is also changing, so it seems like that magnetic field is rotating. So due to that, RMF is produced. RMF means the rotating magnetic field. Okay, now inside there is a rotor, and what happens in the rotor? There is a rotor, and if rotor is stationary and magnetic field keeps on moving, then in that case flux will cut, and if there is flux cut, then flux will change, and according to Faraday's law of electromagnetic induction, EMF will induced, and due to this EMF, current will produced in the rotor. Now there is a current in the rotor, okay, and due to that magnetic field is there. So now there is two magnetic field. One is the magnetic field of stator and another is the magnetic field of rotor. So they'll interact with each other, and due to that rotor starts rotating. So this is how we are giving electrical energy and we are getting mechanical energy. Now in this only numerical. Now after that we'll have two speeds, right? One is the stator key speed and another one is the rotor key speed. Always remember, stator is not rotating. Stator produces magnetic field. That magnetic field is rotating, right? So stator key speed is denoted by ns and rotor key speed is denoted by nr. And there is a concept come over here, that is slip. Slip is always ns minus nr divided by ns. There is a formula. What is slip? Slip is basically the difference in the two speed, rotor speed and stator speed. So slip always vary between 0 to 1. Okay, slip always vary between 0 to 1, and slip is always in percentage, so multiplied by. Now ideally, according to you, tell me, ns की value should be more or nr की value should be more? According to you, tell me. नहीं, ns की speed is always greater than the rotor speed. Reason for that, you are giving direct supply to the stator, right, not the rotor. तो इसको ज़्यादा supply दोगे, that speed is more now, so stator speed is more. Okay, ideally if it's the case of motor, okay, if it will work as a motor, then ns speed is more. If nr is greater than ns, then the same machine will work as a generator. Okay, by using prime mover or extra anything extra any device will increase the speed of the rotor, then it will work as a generator. Now tell me one thing, that if NR is equal to 0, okay, means rotor is not rotating. Remember I told you in the starting that rotor is stationary, right? In the very starting stage rotor is stationary. So at this particular point, if rotor speed is equal to 0 means rotor is stationary, then can you tell me the value of slip? Slip is equal to 1 only now, because NR is 0, NS by NS is equal to 1. So slip is in this case slip is 1. So if numerical will come from the induction motor, then that will be definitely from the slip formula. ठीक है, एंड आईपी में आता है स्लिप पे बेस्ड न्यूमेरिकल. अंडरस्टूड. नाउ आफ्टर दैट न्यूमेरिकल C based on slip, C in particular driven. Now they are asking what should be the number of, as I took is 120 by P. Right? After solving we'll get the as 8. It will get 8.57. Consider, and after that they said calculate the actual the rotor, calculate R, that is minus NS. Slip value they have given 4%, can get the NR value, right? Pole is pole and operates with the slip they have given as 5. Determine, calculate NR. Now for that we choose F is F, we get the NS 120 divided by 6, right? And that would 1000. Now after that we need to calculate NR, so much, that is by NS multiplied by 100. NS calculate 1000. Slip we 5%, 5 by 100. Here can we get the value for NR, and that is of the rotor. Next thing they are asking, there is a relation of between stator and, write it down. FR means C of the rotor is equal to S in F1. F1 is basically the stator frequency, and F basically the, write down, or you can write down FR also. There is a relation formula, so it F2 equal to S into normal frequency of the machine they have given 50, percentage slip also they have given by 100. Get the right? Now they said the speed of the rotor magnetic respect to and the rotor magnetic respect to respect means divide that thing. जैसे कि speed of rotor NR with respect to rotor. See, in today's lecture we'll cover principle of operation, revolving magnetic field, and rotating magnetic field is same. Okay, rotating magnetic field and revolving is same, don't confuse. Squirrel cage, phase wound rotor, starting of induction motor. Okay, so up to here we have covered. Only you are left with the synchronous machine and the direct online or star delta starters. Basically it's a starting method. Okay, So after in the next lecture your unit 3 will be covered. After that I'll start with the unit 4. Okay.